Greetings from Los Angeles. You're watching Tesla Talk TV. I'm happy and sad about this episode. Happy that I talked to a great human being, and sad that we all lost him. I was looking forward to meet him in person, have a drink with him, give him this t-shirt as a gift. And on the back on the shirt it says, "Work for the cause, not for applause. Live life to express, not to impress. Don't strive to make your presence notice, just make your absence felt." I just described for you Mr. Fran McCabe and his life dedication to humankind with over 200 patents, kind words, and great intentions. Fran, from us, Tesla Science Foundation, TeslaVision, and Tesla Talk TV, you are already greatly missed, but you will never be forgotten. Thank you for watching Mr. Fran McCabe's last interview. Greetings everyone around the world, especially you with the positive energy. Today we have a special treat, and where we're going, it's pretty much where all the greatest idea come to the light. And it's a garage, it's a farmhouse, it's somewhere where people at peace, put some thoughts, ideas, and knowledge together. And our guest in Tesla Talk TV today is Fran McCabe. And Fran, I hope I found you in really good spirit and health. How you doing today?
I'm just getting the advanced years, but you know what? When you pile them up, they end up being useful if you can remember them all.
Well, listen, I love talking with I would say senior but more experienced people, because they have always some kind of wise idea, always a wise how should I say, advice. The most important thing is the right advice.
You've learned about all your mistakes. You try not to repeat them, but it takes a lot of work not to repeat your mistakes. But anyhow, by the time you get to this age, you've piled up a few of them. But anyhow, fortunately, I've piled up maybe a few more of positive type things that have worked, so I'm very happy about it.
Okay, I want to ask you, who gave you the best advice in your life, if you could remember, that really pretty much direct you where you were going?
I was just telling Nicole that I worked with an engineer who was a farmer, and then he worked on steel melting furnaces that this company was making. So I was just a draftsman at that time. I was going to Drexel University. And he said, "Fran, don't get a job that you stay in." He said, get as many jobs until you're about your mid-20s. So I ended up with 26 jobs, actually, until I was like towards my 27th year. And he said, learn from each one of these jobs, and when you finally settle down into a job, then you're going to be really you'll be beyond professional just about that point at the get-go. So at age 27, I had all this background thanks to this farmer gentleman that we met working at a company that made steel melting furnaces.
You grew up on the farm? You grew up pretty much around all those machineries?
No, the fact is that I grew up in North Philadelphia. Now, you maybe don't want to hear this, but I was a member of a gang. And it was a bad gang, but not that bad. We were pretty good. But anyhow, I ended up building all kinds of contraptions as a kid. I had this tricycle I built, and then I got that bulletin wagon, and I found out that I could power that, I could use different types of power to power that. And so I worked on so many different things as a really young boy, like about, I guess, 10, 11, 12 years old, to make things that moved, and did all kinds of screwy things, and boats and this other kind of stuff. I had a trike one time I built, and I made everything. Got bicycle wheels put in together. So anyhow, I got started as a real young kid.
So why do you think, that you had that interest, I mean, really kind of getting deep in yourself, did you try to discover or did you just try to be creative?
Well, I have to give credit to my father, who actually was always had something to do, and he would bring me into it. Now he worked me like I mean hard. I'm so proud of that. That he worked me hard, and I never ran out. Excuse me, like my brothers and sisters did. Sorry about that. But anyhow, he was a decent mechanic. He was a lineman for the telephone company, but he had all kinds of curiosity, and he was so happy when he helped me build a garage, and then we built a hot rod shop. So I was like about 17 or 16, 17. We built this garage, and I put up big beams, telephone poles, cross arms that he. Okay, I can't admit. Well, he's gone now, so they'll never be able to prosecute. But anyhow, he borrowed from the telephone company. They were old. They were discarded. Anyhow, so we had this great garage. And I had this bunch of guys that had hot rod cars. So I would build their engines, rebuild their engines, make them faster than the next guy, then make his faster than the other guy. So I had a nice business going. I put myself through college that way. I had a hot rod shop, actually. So then we raced, we drag raced, and we did all kinds of building of roadsters, they call them, dragsters. And the fastest we could go then was like about 144 miles an hour. Now they're doing 300 miles an hour.
Yeah, yeah, yeah. So pretty much your drive was efficiency, advancement, and how to, basically be more what that would be, faster or efficient or.
In a drag race, you want to get there in less than, in those days, 10 seconds was good. Now you're down to about, less than 8, or maybe it's 5 seconds, I think some of these. We were so we do everything we could. We poured out the engines, we put the transmissions in, we put the type of chassis, anti-roll, not the roll bars, but torsion bars. And then so you hold the wheels steady, and then we arranged this one car that would actually have arms that would lift the whole car. In other words, when you go to accelerate, you lift the front end a little bit, but that's not the whole car. If you pushed it from the center of the car up, so we put the torsion bars to the center of the car, and it had to lift the car, and that pushed more down, so you got more acceleration because you had more traction.
So you're very close to flying machine in a sense.
Well, we did have some fun with some speed on those things.
Okay, so your imaginative work, from hot rod, to go almost into the science, how did you kind of break that bridge?
Well, I worked for a lot of years in different companies where I was an engineer. Then I got I got involved with this one company that really was in a mundane thing. Guys always expected me to be in airplanes, and I had a job with North American Aviation in California, and but I didn't take that job. I actually just started working in the damper business. So because I felt there was a lot to be done to save people's lives in building. So in the end, jumping through the whole thing, I worked about 35 years in that field. Started my own company about 2/3 of the way, or maybe halfway through those years, or well, a quarter way. Yeah, so we had about 35 years where we developed smoke control pressurization for buildings that they just didn't have. They just didn't do pressurization. Now, if you're going to stop a fire or stop smoke, which is killing, fire kills very few people, smoke kills a lot of people. So basically what we did was we developed a pressurization system, particularly in the escape rooms, like in a stairwell. We would put a fan in there, or they already have fans in. So then we would pressurize the stairwell. So smoke won't climb uphill. So basically that would bleed out through the building, through the vestibules, through the corridors. If you're in a hotel room and you had smoke control, all you had to do was open the door and you were going to walk out to a clear area that was pressure protected by pressurization. So we spent 30 years getting the codes. We worked with ASHRAE, the American Society of Refrigeration and Air Conditioning Engineers, and we had some really good guys that we worked with. They're top engineers. And so they helped us get this pressurization through all the international codes. So I really got a great thing in my back pocket for my life's work, which is mostly in this smoke control. Then after I sold the company about 10 years ago, then we got involved in all these inventions. Now I'd been involved in some inventions, but mostly they were for the company. So we invented all our own products for the company. So that's when I got involved with all kinds of science of pressurization, airflows, uh, planes of pressure in buildings, and so forth. And that people have said now, and if you don't mind this, that we have saved well over 100,000 lives, they believe, in buildings because of our smoke control system. So when you get that in your life, you can feel pretty good about it. Okay, well, I won't dig them out, but I mean, we have patents for in a lot of areas, a lot of machinery areas. Lately, I haven't followed through on patents because I'm not going to live long enough to use them. But I have the air car, and I do have some progressive patents on the air powered cars, windmill powered cars. Then I went through the company, developing a lot of products for the company, mostly for these pressurization systems that I was telling you about, and then the airfoil for the various uses of the airfoil. And then later, after the company, we came up with different fire protection, smoke protection products. So I patented all of them. They were all our invention. We really only went in, sold, manufactured what we invented ourselves. So we have a load of patents, quite a few on that. And then we moved on into the more ethereal. That was the practical. You have to make money, so we worked on those for years. And when I hit about age 40, 45, I started doing into what I call the WIFTY side of my patents, which started to move into cars, bowers, gyroscopes, and all that various applications. And then airplanes. We built 3 experimental airplanes. NASA helped me build a couple of them, or one. They helped me build one, and that was the fastest. Ended up being the fastest plane, which I ended up crashing while I was racing it in Florida. It was a controlled crash.
Right now, having your shop behind you that we see, there is a lot of, how should I say, idea that you started. Where are you getting your idea?
Well, somehow we got started in gyroscopics and then really into aerodynamics. So both things we followed outside the business. Now we have a windmill company that we own. I sold it, but I own 45%. So we have a very high efficient windmill that will, as a matter of fact, right behind me, you won't see it, but I'm using a Chinese generator that actually takes only 175 RPM to power with our bi-blade windmill, which is patented special airfoils of ours. So we're lucky enough to come onto these. Like the beginning of the airfoil, to try to answer your question, I needed to provide less resistance to the airflow in the product in the company I was working with before I started my own company. And so we ended up coming up with a shape that was really odd shape. And that ends up that it has, Villanova University did a report on it. And it turns out 1.6 times the best airflow. And they said, Fran, it's like impossible. Nobody gets that kind of increase of lift from the airflow. But then we capitalized further on the airflow by coming up with an arrangement. And then how you think of these things, you sort of ask that kind of question. I'm going to tell you, I don't know where that comes from. I mean, if you just seem to be, whether it's luck or you gather, like I tried to explain that kind of thing one time in a conference down in Florida. And because they asked me, how come what makes you into an inventor? And I really have to say that somehow you intuit. God has given us intuition.
Yes, absolutely, I agree. And somebody was saying, and I was reading somewhere, that basically you just have to ask the nature, and nature will provide you the answer. But you need to develop that curiosity and the path in which you will seek those answers.
Yeah, you were exactly right. You have to be a seeker of the intuitive. You get this knowledge. You bypass the basic knowledge, like an airfoil. When you come up with an airfoil, they have Bernoulli and so forth. Now, Bernoulli is, I talked this over with NASA guys. Bernoulli only had about 15% of the lift. We found that there's 3 inertial bases for it. So we went on the basis that, wait a minute, this air has to move to catch up to that airfoil that passes through. So that's one basis of it. Then you have the impact. Then we found that if you bend that air coming off the airfoil at a much more acute angle with more mass of air, so where you intuited this kind of stuff, and then we put this lip on it. And I don't know where that lip possibly have come from, and that we get 4.3 times everybody else's lip on, and now we're able to use that for this with this Chinese generator. And we think we will have finally a small windmill that really works. But really, wind and solar, great things to be pursuing. Don't denigrate them, not at all. But they are not economically viable enough to replace oil at this point. So.
Yeah. Well, let's go back to the beginning. I mean, I'm not gonna start with the Wright brothers, but I'm gonna start with Tesla. When he discovered that stall, and when he discovered, pretty much. I mean, I don't know why he would get into that, at that given time. I understand, that right now we're trying to develop, efficiency with all different shape of airfoil, and just find that difference between the pressure. But amazingly, we are getting in a situation, that nature can work as well differently right now. Right now, even, that gravity, it's in question, how really happens, and that bipolarity, it's everything is right now open for discussion.
Well, Gyroscopics is leading us there. Now, I have this picture of Tesla with his airplane and a patent shown on it right up here, a picture of Tesla doing it. Now, he developed the same kind of a little helicopter type thing that I'm working on myself. But the main thing really now is we are getting into this gyroscopic dynamo with powered precession. Now, like behind me, we're doing a copper magnet power plant. It's a boiler. So we're going to make steam with this. We've already proven this works out. So I'm going to use the gyroscopic machine, which right now I just walked in with this thing. I think you actually can see it with these wheels.
Yeah, I see it. Yeah, I see what you have there. Yeah.
Pound wheel that spins, and basically that will stay up as in precession. Now that's driven by a 1.2 inch-pound, very small little electric motor. It barely spins it. So that the torque output of this is 1.2 inch-pound. Now this is 48 times 25. That's 1,200 inch-pounds to hold this up. So once you leave go of this when it's spinning, it'll stay up. So it's a 1.2 inch, 1,200 output. So it's over unity, which you're not supposed to see much in the world of physics, but it's over unity by 1,000. I presented this to the SSE guys in Boulder during the meeting that they had, and they allowed me to present. And they have a bouncer. The guy stood up to throw me off the stage because I'm going to say something really outlandish here. And this is over 1,000 over unit. So fortunately, I had a video of this, so I was able to push, and it showed it. This is their bouncer guy, Dr. Dobbins. When he stands up, you're off the stage. But he just sat down when he saw that. So we proved to him that we had 1,000 times over unity. And that doesn't happen in the world of physics. That's part of what I was saying earlier, that we want to make sure that works. All right, so we're trying to get this to heat up this copper. And the gyro makes this huge amount of over unity work. Now, right now, we're looking at well over 200 times. In other words, we put in let's say 30 inch-pounds with two motors, one that spins the wheels and one that powers the precession. And the power precession, remember, that's the big secret. It's our big breakthrough. I mean, it's a miracle that we intuited somehow into that by however, I can't even tell you, but it's there. Even Sperry, I'm amazed that Sperry didn't accidentally get into this. And I can't believe that Eric Whiteway, the top guy who ran Imperial College, he gave me the credit. He said, Fran, you're ahead of me. And he had worked in gyroscopics years at Imperial College. So somehow we broke through this we were led through by intuition. So now we are using this over unity principle, and we're trying to make that to do all kinds of work. So that means that if this can be made to work, you're going to end up using, let's say, the power, all the power to make automobiles work. I just showed Nicole how we would drive an automobile with this. And we have a little model here. And if all this power is used, you're going to cut the need for oil. You're going to cut not by 1% or 2 or 5. You're going to cut it by about 60 or 70% if you can use if these machines go where they already have proven. I mean, I don't like to talk about anything that we have that's just our wishful thinking.
Sure.
You really have to get some hardware in place. So we do. We have 3 or 4 of these now, and we're going to go into a boat propulsion using gyroscopic over Unity, and right now I'm able to get 75 times the input power. Just a little fishing boat. We're going to build that with gyroscopic.
Usually in this type of production we have two obstructions. One is funding, budgeting, experimenting to work with that, and the second one is also the industry very well established, that is threatened by something like that. And where do you think that we should expose you to the people that are watching the show to come up and help and pretty much get involved in speeding up your ideas?
Very good pun there, spinning up.
Yeah.
Very brilliantly observation, as they say in Ireland. But anyhow, my first goal is to get the academia people on board. And they are right now, I have to say this, I'm sorry to say this, but they basically, I'm going to use the blockage. There is a blockage in academia to go into gyroscopics past what they think is basic physics. This is not basic physics. You can take some real top guys like Tom Malone and let me do a talk at the University of Maryland and so forth about it. But you have to vet this thing through. I'm trying to get academia. I give lectures in colleges now, and when I get to Belgrade, they let me do one lecture on aerodynamics. I hope they let me do one on gyroscopics in this visit that's coming up. Then I'll be out there in 2 weeks. But you have to, I'm trying to get the basic physics to include gyroscopics. Without that, I think we're going to really we'll be blocked every step of the way. You got to get academia to accept gyroscopics that you can power precession. Now I'm going to jump to a pretty big jump here, and that is gyroscopics are the basis for forming. We can all look at how the planets come up. They are from powered precession of the elements that go into making up a solar system or a galactic system. And if you look at all these things, everybody knows that you see this spiral, and it's really a vortex. Now you really have vortex energy in gyroscopics. That's the basic thing that you have once you power the precession. So instead of just this precession that stays in a stable plane, you now form a spiral. And then the upward force of that spiral, H I think Planck called it for some reason, that is a tremendously powerful. That's where the over unity comes in. That's where mainstream physics has got to get into this, prove it to themselves, let some of our demonstrations show something. I'm a kludge as far as building things. So, and then I don't do real good note-taking and analysis. So I got to hire some people to actually, that's what I need help in. Somebody who would write some of this stuff up in a way that mainstream physics would accept it. Then we jump into the applications, whether it's going to be for lifting huge weights. You could lift huge weights, or you can do this copper magnet thing that we're doing, or you can compress air, or you can do whatever you want. And I don't know, it's a strange thing about making electricity. It seems like the gyroscope does not like magnetics. It's amazing, because I dealt with 2 top PhD guys who had another consultant PhD guy, and they thought magnetics was crucial to gyroscopic. I measured in Teslas. I have a Tesla meter in my iPad, and I measure the Teslas in all these devices, and they are not showing any increase of magnetics. And then I learned through a note that I got from somebody from Tesla that said, don't use steel, don't use magnetic material. So I switched to aluminum, and it went to be over 10 times the performance by following Tesla's approach of using non-magnetic materials. But right now, everybody thinks magnetic materials are the answer. So anyway, all this is a bunch of detail, of what I'm working on. But there's a lot to get done. I need real help in just getting some of the work done, but really I'd like to help in the physics.
Well,
Mainstream.
Fran, as you know, the school will produce very great intellectuals, but not necessarily inventors and visionaries. And it's a good, when your idea can get to the implement, that scientific thought, into real, how should I say, lectures and professors and somebody, that can analyze, that idea and determine, how to work it out. So that's a good bond, what you're doing, trying to invest your time in some university and basically, how should I say, tic tac, people to think in your direction in order to help you out develop that idea.
Develop for mainstream physics. Just get it in the physics books. It's not in there. They don't put gyroscopics much, hardly anything in the physics book. They don't even put much beyond Bernoulli and aerodynamics either. So that's another contribution we're hoping to make there.
Okay, so what do you expect, with your trip to Belgrade to university? You just gonna meet people, gonna kind of establish, how should I say, some relationship? What's gonna be there?
Well, there are people there that are working on gyroscopics that Nicole told me about, so I want to do that. I want to get backing from the Tesla Foundation there, and the museum people, to step up the backing of the physics behind gyroscopics, or in any way, even if they just want to take some of the demos that we have and show them around. We have reasonably good videos, I think, of them. So yeah, I'm trying to develop a network from where Tesla really was a kind of guy that just moved things forward to unbelievable places. So
Yeah.
this gyroscopics is one of, I think, a Tesla-like unbelievable place. So we hope to get whatever help. And I know that people that are backing Tesla, they're going to not be afraid to back. There's even Tesla even did. He knew Jerry Sperry's son. He palled around from what I gather, Sperry's son. So they were into gyroscopics. Tesla was into gyroscopics.
I think it's a great idea, bringing two nations together and kind of involving universities, in helping you out develop that intellectually and on paper, and as well, hopefully, that whole country will stand behind you, because developing something like that, would be tremendous honor to legacy and name of Nikola Tesla, as well yours, because absolutely you're the one who is pure energy right now behind this project. So I really, really would like to wish you good luck, and great success. And we'll do everything in our power, to promote such a very, very interesting and curious idea.
All right, thank you very much.